Hi everyone, we are from Group 4.
Our question is, choose 3 different types of pen and study the heat conduction through the bottom of a pen in different heat transfer regimes. And we have to propose the best pen for cooking. The first type of pen that we choose is aluminum pen. Aluminum pen is usually low cost and non-reactive. And the brand that we choose is Genway Heavy Duty Aluminum Fry Pan.
The pros for aluminum pan is it is low cost and have great thermal properties. And the cons for aluminum pan is sometimes it is very expensive, it's stainless steel. It is highly reactive to acid ingredients lower density, and aluminium is prone to scratching.
The next type of pen that we choose is cast iron pen. Cast iron pen is a thin but durable non-reactive layer of glass fused to the surface of the utensil. And the type of brand that we choose is Le Creuset cast iron fry pan.
The pros for cast iron is it is low cost and it is thick that results in even heating. The cons for cast iron pan is it is high capacity that makes the utensil takes longer to heat up, and it is extremely hard that can crack or fracture if dropped.
And the last type of pen that we choose is copper pen. Copper pen is a soft but durable material that has great thermal properties. And the brand that we choose is Movil's M250C.
The pros for copper pen is it is high thermal diffusivity with enough thickness, and it is extremely responsive. And the cons for copper pen is it is heavy, extremely expensive, copper surface can tarnish or scratch, pan may cool too fast after remove heat, and the cooking directly on copper may result in undesirable levels of copper intake.
Okay, in the most cooking application, it is desirable to have the utensils heat up quickly. Materials with high thermal conductivity fulfills our need. They transmit heat quickly, resulting in fast response to thermal changes and even distribution of internal kinetic energy. The aim of this problem is to compare on which pan is the most suitable for cooking purposes. Thus, we have to calculate the heat transfer rate of each pan to see whether which pan produces the greatest heat energy. For every problems, we have to start up with an assumptions. In this particular problem, we do know that it operates in a steady state. Heat are transferred in one dimensional and no heat is generated throughout the system. The heat radiation and the kinetic as well as the potential energy are negligible. The thermal conductivity of each of the pan are constant. The diameter and the thickness of each of the pan are also the same. Next, we go on with this analysis. As we know that the thermal conductivity of a copper is 401 volt per meter Kelvin, whereas the cast iron has the thermal conductivity of 80 volt per meter times Kelvin, and finally our aluminium has the thermal conductivity of 237 volt per meter Kelvin. The diameter of the cast iron pan, the copper pan, and also the aluminium fry pan is 0.28 meter, and the thickness of each of the pan has the same thickness, which is 0.01 meter. So we have drawn the image of the pan that is being heated. We have listed down certain properties of aluminium, cast iron, and also the copper. As you can see at this part here, we have listed down the aluminium's thermal conductivity is 237 volt per meter dot Kelvin, as well as the diameter of the aluminium is 0.28, and the thickness will be the 0.01, which will be the same for each of the metals that is listed here. Next, we'll move on with this graph. I have plotted a graph on a rate of heat transfer versus the thermal conductivity. The thermal conductivity and also the rate of heat transfer. We can see that the thermal conductivity of an copper lies at 401, which is at this position, and this shows that the copper pan has the highest heat transfer compared to the aluminium and also the cast iron. As we know that when our thermal conductivity increases, the rate of heat transfer also increases, and it is directly proportional to the thermal conductivity. So we can conclude that as the thermal conductivity increases, rate of heat transfer also increases. Thus, the food inside the pan will get much more hotter at a faster rate. So our conclusion will be the copper is the best pan for cooking because it has the high thermal conductivity as well as the high rate of heat transfer. That's all from us. Thank you so much for listening.